right, so evaluate the 6 trig functions for theta equals 210 degrees. First thing, where's 210 degrees, right? Well, 180 is that semicircle, right? 210 degrees is in the third quadrant. Let's draw it down here. Might not be in the perfect spot. Now again, I'm not, because this is in standard position, I'm not drawing 2 lines. I'm just drawing that one terminal side in the third quadrant. This is 210 degrees. This entire angle here is 210 degrees. We need to know the 6 trig functions, the value of the 6 trig functions for that. So they want to know, or I want to know, what's the sine of 210 degrees? We'll flash back to here. The sine of any angle is the y-coordinate of that angle on the unit circle. Okay? So if you have the unit circle memorized, 210 degrees down here, just start knocking them out. Okay? But we're going to take a different approach because I told you, don't think about the entire unit circle. Let's use this idea of bow ties and butterflies, if you will, right? So let's look at an angle. Let's look at the angle that uses this terminal side as a quote-unquote diameter of the unit circle, and that would be the angle that comes through here. Right? So if you think of this as one of those diameters of the unit circle and use this concept of bow ties and butterflies that we discussed, then the coordinates of this point are the same, have the same absolute value as the coordinates up here. And you should definitely know your unit circle coordinates for the first quadrant at least. We know that those are radical 3 over 2 and 1/2. So down here, because we are in quadrant number 3 with this terminal side, the coordinates would both be negative. So we have negative radical 3 over 2 and negative 1/2 as our 2 coordinates. You're not always going to have that unit circle in front of you, basically, guys, okay? And so you have to think about ways, shortcuts, things that'll work for you. If you have a photographic memory, if you are just somebody that wants to do that and memorize that, more power to you, okay? But in my opinion, that you're taking up space in your brain that you can use for other things. I think this makes you a better problem solver, okay, rather than just trying to memorize that shape. So when you look at this, you want to know the sine of 210 degrees. It's the y-coordinate of 210 degrees. That's negative 1/2. The cosine of 210 degrees is the y-coordinate, or excuse me, the x-coordinate. Now remember what we said about this too. 210 degree angle, right? So we know, and I don't think I've ever done this before. I'm going to do this for you guys. If you look at this angle, this 30 degree angle, and this angle down here, they're vertical angles. They both employ the x-axis and this diameter to help form them. So this angle and this angle, they're congruent, right? So, and this is the concept, this is the baseline for what we call reference angles. Okay, a reference angle for an angle is that acute angle that it forms with the x-axis. And because this has a reference angle of 30 degrees, I can use 30 degrees to help me answer questions about this. All right, we talked about how a 30 degree angle on the unit circle is further, its intersection point with the unit circle is further away this way than it is this way. So its x-coordinate, the absolute value of its x-coordinate is larger than the absolute value of its y-coordinate. So that's how I know this number is going to be bigger than that. We talked about that last week. So the square root of 3 over 2, but we have to make sure that's negative. Now let's talk about tangent. Let's take our time here. The tangent of 210 degrees is the y-coordinate over the x-coordinate. I'm going to have a much better shortcut for you in a little bit, not today, okay? But if we take the y-coordinate and we divide it by the x-coordinate, right? Tangent, y over x, the y-coordinate on the unit circle divided by the x-coordinate. We have 2 negatives. So what's going to happen? That's going to be, they're going to cancel. It's going to be positive, right? Which leads to another discussion about how tangent values are always positive in the third quadrant because you're always going to have negatives over negatives, right? All tangent, and that's where using the calculator totally messes you up. Again, we'll get to that. But here you have y over x, right? Looking like this fraction, right? And this is where our fraction skills and our radical skills come into play. Because what do I do with this? Well, since I am dividing two fractions, this is really 1/2 divided by radical 3 over 2. I've gotten rid of the negatives because they're unnecessary. They cancel each other out. And dividing two fractions is the same as multiplying by the reciprocal of the other. Follow? Flip this one over. Multiply. Now when we multiply, we can cross cancel those 2's. And we end up with 1 over radical 3. Which is not good. We're not supposed to have radicals in our denominators. Let's rationalize the denominator, multiplying by radical 3 on the top and bottom. Presto changeo. Our tangent is radical 3 over 3. Now, like I said, there is a shortcut for this. I will explain it probably when we talk about inverses. I'm going to make you work the fractions a little bit more. Our cosecant theta is the reciprocal of 1/2, which is -2, right? Notice I didn't write 1 over y. I told you this. You know, yes, this could be some formulaic way of finding cosecant, but it's better to find sine and then flip it over. So we find sine as -1/2, flip that over, -2 over 1. You'll see this again when we start graphing trig functions. It's actually better to graph sine when you're graphing cosecant. When you're graphing a cosecant function, we graph the sine function, and then we flip it over. You'll see. All right? The 4-letter F word. What's the 4-letter F word? Flip. Good. All right? See where I went with that? That was a joke. Okay, good. The cosecant of 210 degrees. If we flip this over, secant. The secant of 210 degrees, we're going to flip this value over. It's going to be -2 over radical 3. Shouldn't have that radical 3 in the denominator. So, radical 3 on the top and bottom here. We get, run out of room here. Secant theta is -2 radical 3 over 3. So we have secant theta here. We have cosecant theta here. Uh-oh, my smartboard's not. Now cotangent. Here's where I can tell you one piece. Now cotangent is the reciprocal of tangent. Okay? Now this is what we wrote as tangent before. So you can reciprocate tangent at any step in this process. Because basically once we got to here, y over x, it was just a bunch of simplification until we got to the bottom line. But at any one of these steps in this process, we have the tangent ratio set up already. So to find the reciprocal of this, you can reciprocate, if you will, any part of this that's going to make it simpler. Like I could flip this over and then go through this entire process. I could say that the tangent of 210 degrees is this, and I could flip that over. But what's going to happen if I flip that over? There's a radical in the denominator, which is not, end of the world. But at one point in this process, we said that the tangent of theta was this. Tangent of 210 degrees, sorry. We said tangent of 210 degrees was here at one point. So what if we reciprocate that? What do you get?
Square root 3.
Radical 3. Right? So the point being, if you want to take cotangent, reciprocate tangent, take the reciprocal of it. Just find where it works best for you to reciprocate that. Right? So we just get the square root of 3. End scene.